this lesson, we're going to look at solving a system of three equations with three variables. So it'll look something like this. In order to do this, what we need to do is take two of the three equations and do either substitution or elimination on them to get rid of a variable. So then we'll be left with an equation that has just two variables in it. Then we're going to take a different two equations and do that again. And we have to make sure that we try to get rid of the same variable so that the second time we do substitution or elimination, we end up with an equation that has the same two variables as the first equation. Once we've done that, then we've got a system of two equations, and you can solve that exactly like you solved it in 3.2. Once you get a number for those two variables, you can take that, plug it back into one of the original equations, and find the third variable. All right, let's work through one of these. So looking at the first two equations, so we'll just totally ignore the third equation for now. I'm just going to cross it out. Let's not look at that right now. If we look at the first two equations, I could maybe do elimination with the x's. So the top equation has a 4x, the bottom equation has a 2x. If I just multiply this entire thing times -2, then I'll get -4x. That'll be positive 6y minus 10z equals positive 28. The top equation I will leave exactly as is. So then we have the positive 4x and the negative 4x. Those will cancel each other out. All right, then we're going to add these two equations together. So the 4x and the negative 4x just cancel each other out. We're left with nothing. We get 8y and then negative 7z. Add 28 and 1 together, we get 29. So now we have an equation that has y and z in it. So we're going to set that aside. We'll come back to it. But what we want to do now is take a different two equations from this set of three. And then we're going to do either substitution or elimination on them again in order to make this make another variable get eliminated or substituted in for. So this time I'm going to take, how about the bottom two equations? So just by nature of having three equations, we're going to have to reuse one of them, but that's just fine. We'll take a look at the bottom two equations here. So I'm going to look at how to get rid of x. So maybe I'll multiply this middle one by -3. So that'll give me -6x, positive 9y, negative 15z, and then positive 42 at the end. All right, then we want to add the two equations together, these two here. So the x's drop out. Now it's very important when you do the second one that you make sure to get rid of the same variable. So in the first equation, boxed in green to the right, we got rid of x. So we got to get rid of x in this one too. So that's why I was looking to multiply by -3. All right, negative y and 9y together makes 8y. Then let's see, 4z and negative 15z makes negative 11z. And 42 and -1 makes 41. So now we have a second equation that just has y and z. Now I can take these two equations here and make a system of two equations. So if we look at the y variables, those both have 8y. So I can make one of them negative. So let's take the red one, multiply everything by -1. Bring it over here, so times -1. That'll give me negative 8y, positive 11z, and negative 41. Now I can add those two together. So 29 plus negative 41, that's going to be -12. Negative 7z and 11z will give 4z, and then the y's drop out. Now I've got 4z equals -12. I can solve this for z by dividing by 4, and we get z equals -3. All right, we found our first variable, but now we need to find the other two variables as well to get the solution. So to find, say if we want to find y, we can take one of these equations that has both a z and a y in it, plug in the z value we just found. So we'll take this z equals -3, plug it right in here for z. So 8y equals, minus 11 times z, which is -3, equals 41. 8y then plus 33 equals 41. Then to solve this for y, we're going to have to subtract 33 from both sides, where we get 8y equals 8, divide both sides by 8, and y equals 1. Now we've found two of the three variables. In order to find the last one, we're going to have to go back to one of the original equations. And it doesn't matter which one, but we're going to want one of those three original equations. And then we're going to take our value for z, take the value for y, plug them both into that equation, and then solve it for x. I'm just going to take the first equation, but again, it does not matter which one you do. So 4x plus 2 times y, which is 1, plus 3 times z, which is -3, equals 1. And then we just go through and work this out. So 4x plus 2 minus 9 equals 1. 2 minus 9 is -7. Add 7 to both sides. 4x equals, let's see, that'll be 8. Divide both sides by 4, and we get x equals 2. All right, so remember that solutions to a system of equations, these are coordinate points. So we have a ordered triple here, actually. So ordered pair would be for your normal graphing where you have x and y. But if we have three values, x, y, and z, we're going to have an ordered triple. So x value goes first, so we get 2 for the x value, 1 for the y value, and -3 for the z value. So the coordinate point 2, 1, -3, that is the solution. So that is where all three of these planes, so remember each of these graphs has a plane, represents a plane, a two-dimensional plane. And so this point here, this is where all three of these planes intersect. Now there's a couple things just to remember. So sometimes when you go through and solve a system of equations, you will have all the variables drop out, and you'll get something like, maybe like this, 5 equals 5, or some true statement. So remember that solutions to equations are values for x, y, or z for the variables that we could plug in that will make the equation true. Well, if we look at something like 5 equals 5, no matter what x, y, and z are, that's going to be true. So it doesn't matter in this case if that's what you end up with when you try to solve your system of equations. If all the variables drop out and you get a true statement, then that's just a system of equations that will always be true. It will have infinitely many solutions. If you have the same thing happen where the variables drop out, but you end up with something like 2 equals 5, which is obviously a false statement, this would mean that there's no solution. So again, if we're looking for numbers that we could plug in for x, y, and z that would make this equation true, 2 equals 5, well, there is no value of x, y, or z that would make 2 equal 5. 2 never equals 5, no matter what x, y, and z are. So this would mean that there's no solution here, which means there's no intersection between those planes.